Hi students, in this video we will discuss some more problems. I'll read the question now. Evaluate integration of cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. Here in the denominator we have two different terms, that is binomial, so we will try to convert them into monomial, otherwise we will try to cancel it now. Okay, but already we know the formula for cos 2x. There are four different formulas for cos 2x, but here we will use cos 2a is equal to 2 cos square a minus 1, because here all other terms are in cos. So hence if we try to apply this formula, it will be helpful for us. So we are writing cos 2x is equal to 2 cos square x minus 1, and then this minus sign as it is. This cos 2 alpha can also be written as 2 cos square alpha minus 1 divided by denominator as it is, and then we are just removing this bracket by multiplying this minus sign inside the bracket. So 2 cos square x minus 1, this minus 2 cos square alpha, minus into minus plus 1 dx. This minus 1 plus 1 will become 0. We have 2 cos square x minus 2 cos square alpha. We can take 2 as common, so we get cos square x minus cos square alpha. It is in the form of a square minus b square, and in the denominator cos x minus cos alpha. So a plus b into a minus b. So that now we have removed this denominator and numerator. So here we had two terms, that is binomial. Either we will try to convert this as a monomial, or we will try to cancel it. Here in this problem we cancelled it out. So now we have cos x plus cos alpha. You know that it can be integrated separately. So 2 into integration of cos x plus integration of cos alpha d alpha. Here alpha is a constant. Here we are integrating with respect to x. That's why this cos alpha should be considered as the constant. We know the formula for integration of cos x is sin x. This cos alpha is a constant. Integration of dx is x. So when we multiply this 2 inside the bracket, we get 2 sin x 2x into cos alpha plus c. I hope you understand this problem. In this problem we will try to apply cos 2x formula. Even though we have 4 different formula for cos 2x, we prefer to use cos 2 cos square x minus 1, because here every term is cos. That's why we are applying this formula. I hope you understand this problem. Now we will move on to the next question. The next question is, evaluate integration of tan inverse of root over of 1 minus cos 2x divided by 1 plus cos 2x. If you are good at inverse trigonometric function, it will be very easy for you. Here we have tan inverse, hence we will try to bring tan function here. Before we bring tan function, the square root should be removed. So we have to apply the formula that 1 minus cos 2x is equal to 2 sin square x, and 1 plus cos 2x is 2 cos square x. We saw this formula many times in inverse trigonometric function. So I am directly going into the concept. So 2 will get cancelled. We will get tan root over of tan square x. Root over of tan square x is tan x. So here we achieved our aim. Here tan inverse is there, here tan is there. So when we get tan inverse of tan x, it is equal to x. This integration as it is dx. X dx means you know the formula that x square divided by 2 plus c. If you are good at inverse trigonometric function, this problem will be very easy problem for you. Now we will move on to the next question. Evaluate integration of sin inverse of cos x dx. Here we have sin inverse function. If we have sin function here, it will be easy for us to solve the problem. Hence we write this cos x as sin pi by 2 minus x. Sin inverse of sin pi by 2 minus x means it is equal to pi by 2 minus x. This integration as it is. So we can separately do the integration. Integration of pi by 2 dx minus integration of x dx. Here we will get pi by 2 x minus, here integration of x is x square by 2 plus c. I hope you understand this problem. As I said earlier, these are inverse trigonometric function concepts. Next we will move to this problem. It is also an inverse trigonometric formula. Concept. We solved this problem again in inverse trigonometric function. So we will see this problem. Integration. Our aim is to bring tan function here. Here we have secant and tan. Power 1 is there. As I said earlier, we will try to convert them in terms of sine and cos. Secant x can be written as 1 by cos x, this plus sign as it is. This tan x can be written as sin x by cos x. Denominators are same. It is a fraction addition, so we can add the numerator 1 plus sin x divided by cos x. Here we don't have any formula for 1 plus sin x. So what we will try to do is we will try to convert this in sin x in terms of cos x. So we can apply cos 2x formula. So sin x can be written as cos pi by 2 minus x. Here angle is x, here also angle is x. But in this, if when you convert this cos pi by 2 minus x, angle becomes pi by 2 minus x. Hence in the denominator also we will try to bring the angle as pi by 2 minus x. Hence cos x can be written as sin pi by 2 minus x. Already we learnt this 1 plus cos 2a is equal to 2 cos square a. Whatever angle is there, half of that angle must come. Hence 2 cos square, whatever angle is there, we need half of it. So pi by 4 minus x by 2. Similarly in the denominator we have sin 2a means 2 sin a cos a. Whatever angle is there, half of the angle must come here. It will be compared with sin 2a, we get 2 sin a, half of this angle, into cos, half of this angle. We can remove this 2 and 2. This cos square x and this cos will get cancelled. We will get cos pi by 4 minus x by 2, sin pi by 4 minus x by 2. Here we have tan inverse. Here we get cot function. So we will try to convert this cot function in terms of tan function. We know that cot function can be written as tan pi by 2 minus theta. So tan inverse of tan pi by 2 minus whatever angle is there. So when we multiply this minus sign inside, we have tan inverse of tan pi by 4 plus x by 2. When we take this, we will get pi by 4 plus x by 2. We can do the integration separately. You know how to do it. So we get the final answer is pi by 4x plus half of x square by 2. When we write the final answer, we get pi x by 4 plus x square by 4 plus c. I hope you understand this problem. This video problems are all related to inverse trigonometric functions. If you are good at inverse trigonometric functions, these problems are very easy to you. Thank you students. Thanks for your cooperation.